Hello again, it's Lego Mr. Niway. Today we're doing a lab where we're taking a look at how water can actually be contaminated by different things that can seep into the waterways, and then eventually we're going to have each of these contaminated water portions end up in our lake you can see over there in the corner. So we have, for our examples, water-soluble contaminant, liquids less dense than water, liquids more dense than water, sediment, pet waste and or sewage, and litter. You can see on your worksheets that you should have in front of you that each of these things is going to be represented by a regular kitchen household item. So we're going to start adding those just to kind of see how things break down. So first of all, our water-soluble contaminant is going to be represented by food coloring. So I'm going to pop a couple drops in there and then we're going to see what happens. Okay, you can see we got some yellow food coloring here. So we're expecting, since that is a water-soluble contaminant, we're going to see something going on with that yellow food coloring. Okay, so I imagine we took a pause and we are going to now see what happens. Make observations. Describe how it behaves in the water. What properties does it have? Is there density? Is there solubility? How is it behaving within the water? Okay, we should have our observations there, and I am going to slide over to liquids less dense than water. So for our liquid less dense than water, our example for a household item is going to be common kitchen oil, which also is kind of yellow in color, but hopefully you're going to see a little bit different reaction. So I'm going to grab that. Okay, and here's our vegetable oil. Same set of questions, considering density, describe how it behaves in the water, what properties does it have, what is its density, what is its solubility, what are we seeing with the vegetable oil, a liquid less dense than water, and what might that be similar to in nature. Okay, as I'm moving down the line, we're now looking at liquids more dense than water. For that, we're going to use corn syrup. But we did add some color to our corn syrup, so you can see that it's red in color to make it easier to see as you are doing your observations and describing what happens in the water. Okay, so what happens with liquids more dense than water? And was your prediction correct? Okay, here I am at our sediment location. Our sediment is going to be represented by cocoa powder. And let's make a prediction, and then see what might happen as we add sediment to our water. Okay. Making observations, writing our notes about sediment. Okay, we've moved on to our pet waste and or sewage. That's going to be represented by just some regular coffee. So making a prediction of what will happen there. And drop that in, and then we'll give it a little swish like we did with the sediment. And what do we notice? Again, now that's harder to read with the coffee on the side of the thing. That's pet waste or sewage. Okay, finally we have just your basic litter like you might see in a park. Litter is going to be represented by our holiday sprinkles. And what do we think is going to happen with that? Making observations. Writing down notes describing what happens. Cody, do you want to take one last look? It's been about 3 minutes since we put the litter into the last site that is being contaminated by water pollutants. You want to take one last look at kind of everything in a wide angle, and then we'll zoom in before we combine them into our lake. So our water-soluble contaminants, reminder that was represented by yellow food coloring. Liquids denser than water, that was represented by kitchen oil. Liquids more dense than water was Karo syrup, corn syrup. Sediment was cocoa powder. Pet waste and or sewage was coffee. And litter was represented by Christmas sprinkles. Okay, so let's take a look at what our lake looks like before any contamination hits it. Okay, here I am down by the lake, and the water looks clear. I mean, if it weren't so cold, this would be a great day for a swim. But I'm a little concerned that some of our water contaminants might get into the lake. And then we're going to have to consider the question of what actually happens. You know, each of those contaminants on their own may not seem that bad, and we can separate them out. But let's see what happens at the lake. Here comes the litter. That was litter. Water-soluble contaminants. Liquids less dense than water. Liquids more dense than water. Our pet waste and sewage. And our sediment. And on second thought, I'm not sure I'm going to go for that swim. But I do think we've gotten to a point where we can have a nice discussion about what's going into our water.